Welcome and thank you for joining the sixth and final session of this first series titled Private Endpoint and Private Link Service in Azure, The Art of the Possible. My name is David O'Keefe and I will be your host again for today. The session is being recorded. If you don't wish to be recorded, please drop and you can watch the recording later at aka.ms/AZ networking sessions. During the session, we'll share a link to collect your feedback, whether this is your first session or your sixth session. We'd love to hear from you. The agendas, FAQs, and feedback forms for the sessions, as well as the recordings and additional materials can be located again at aka.ms/AZ networking sessions. Here is the agenda for our event today. We'll start with Nahali to discuss Private Link and the Private Link service in Azure. Next, we will jump into multi-region design with Daniel Mauser, and we will finish up with an overlapping IP use case with Shruti Vijaya Nair. As a reminder, here is the core team developing the content, organizing, and producing these sessions. Again, we'd like to say a huge thank you to the moderators supporting us today. Please remember to use the Q&A panel throughout the session to ask your questions. Here are your presenters for today's session: Nahali Niyogi, Daniel Mauser, Shruti Vijaya Nair from Microsoft. And without further ado, I'll pass it over to Nahali to kick us off. Please take it away, Nahali.
Thank you, David. Let me share my screen. Hi, everyone. Welcome back. Thank you to our moderators for supporting this live event. And thank you to our two guest speakers and global black belts, Daniel and Shruti, for being available to present today. So this is the last session of the series. I can't believe it's been 6 weeks since we started this journey together. We do have another cross-functional series planned out for the summer into fall timeframe, depending on my availability. So be sure to check out updates on LinkedIn and on GitHub. In the meantime, I am planning an Azure 100 level session for Microsoft Aspire hires or for folks new in their career or early in their career. So if this is of interest to you, do let us know. All right, so let's get started. So what you see on my screen is a hub and spoke architecture that we have been working with, the top half being the hub and spoke architecture in Azure, and then the bottom section are the privately connected branches. One is the site-to-site connected branch, and another one is an express route connected branch. Private endpoints and private link go hand in hand with DNS. So I covered a lot of this in my DNS session, but I'm going to do a quick recap of what we learned just to complete this discussion with the DNS as well. So as you can see, from a placement perspective, we have an IaaS-based DNS server in the hub VNET, which is a centralized model. This is a shared services VNET. And then, of course, in the spokes, we have a VNET level DNS server. And then there is a DNS server on-prem. So I'm going to take a few minutes to go look at some of the DNS scenarios that we looked at in the previous session. So let's take a closer look at how DNS is set up in this hybrid DNS architecture. And here you will see that let me go through a few components. So here you see that we have a private DNS zone, and it has a record for storage in this case, and that is a private IP. And another important bits in this design are these VNet links that links this hub VNet to the private DNS zone. And then we have two places where the DNS is configured. One is at the VNet level, the DNS is configured. And then there is that default Azure DNS, the 168 IP that we looked at, right? So now that we have seen all of the bits, and then of course we have this on-prem sites as well. Let's quickly look at the DNS flows and how it works. So first we will look at how the resolution works within Azure, and then we will look at how it works from on-prem. So the pink flows are showing how DNS resolution for this private DNS zone will work from Azure. So of course, it would first consult the VNet level DNS, which in turn will consult the Azure DNS, and by the virtue of these VNet links, you would get the private IP of the storage account. All right, so that's within Azure. And then let's look at the consideration from on-prem and how the flows will work. Again, on-prem cannot route to this 168.63 IP, the Azure DNS. So we still need a routing between this DNS server and this DNS that is hosted in Azure. And the green flows show how the DNS query would work. So first it would consult this local DNS. There is a conditional forwarder to the DNS that is hosted in Azure, and then another global forwarder, the number 3 of the leg that goes to Azure DNS. And then finally, the fourth leg that links the VNet, and you get the private IP. All right, so that's the overall flow. And to complete the full picture, if you were to resolve external sites, and we did the example of MIT.edu, for example, these orange boxes are showing recursive lookups. So in Azure, the Azure's DNS would do a recursive lookup and hunt down the IP for you. And for on-prem, you would have the local ISP's DNS, right? So this model, this full picture that you see over here, is a very popular design. We call it the hybrid DNS design. Of course, it is using the IaaS components, right? This DNS server is IaaS based. So what we did was we also looked at an alternate design, which is very similar to this design, also centralized approach. However, it uses Azure's private DNS resolver. So from the flow perspective, it is identical to what we just looked at. So let's quickly look through the flows. And of course, this is on-prem to Azure resolution, and then this is Azure resolution. The blue flows are showing resolution within Azure. The main difference or the key component in this design is the forwarding rule sets. And be sure to check out the DNS video for a deeper dive on this as well. So for this session, we are going to use the IaaS-based DNS design. All right, so let's quickly recap. So this is the central DNS server. And if you want to look at the flows, you can always light up this optional DNS layer. It does get a little cluttered, so I've made it optional. All right, so with that, let's go to our first option. So before we get into private endpoints, let's look at the evolution of the private endpoint service, right? So this is a service called Service Endpoint. It's very similar to private endpoint. It was released before private endpoint, but the idea is the same. The idea is that you want to privately access these Azure PaaS services. So imagine that you have all of these PaaS services and you want to access them from this spoke in Azure without actually going over the internet. So that's the root, that's the use case for this. So let's see how we can do it. So there's a few things to see over here, and I'll go through each one of these individually. So when you enable a private service endpoint, it gets enabled at the subnet level. And then what happens is from this subnet, any traffic that's going to the PaaS services. So let's say we enabled the storage for private for service endpoints. Any traffic from this web subnet to storage would traverse the Azure backbone. And behind the scene, it uses the UDRs to override the system-defined routes. All right, so that's the green flow going from Azure subnet to a PaaS service. Now notice the on-prem flow. The on-prem user still uses the public IP and the public FQDN, right? So it still resolves. So the storage blob.core.windows.net still resolves to a public IP, and it goes over the public internet, but we use the firewall on the PaaS service to whitelist that IP. And then we deny everything else, right? So that's how it works with service endpoint. So what are some of the considerations with this design, right? So let's look at the considerations. So one of the biggest things you noticed is that it's still this traffic, the green flow from on-prem, still goes over the public internet. So with service endpoints, you do not get a connectivity over the express route into the PaaS service. All right. And then the second consideration is, imagine you had another storage account over here, and it was something that you didn't want this subnet to access. You don't get that level of granular control out of the box. Of course, to do that, you could enable service endpoint policy, but be sure to check out that policies are available for other PaaS services. We continue to evolve there, but today it's available for storage account to make it more granular. And this is again to restrict data exfiltration to different storage accounts. All right, and then I just want to show you how, from a configuration standpoint, how that looks like in an Azure subnet. So if you go to the Azure subnet, the service endpoints, if it is enabled, it will show up over here. So in my case, I have it enabled for Microsoft Storage. And then this is the UDR that I mentioned that behind the scenes gets created, and it overrides the system route, and it goes over the Azure backbone. Notice no DNS required in this scenario because it uses the public FQDN. All right, so with that, let's go into the next option. So when you use this draw.io file, be sure to uncheck everything that's in the previous option so that the right things get lit up for the next option. So in this option, we introduce the private endpoint, private link, and private link service. So let's look at the terminology first. As you probably noticed, I have these three icons listed over here, and those are three distinct services. So I want to make sure that we have understood the terminology here first. So before I go in the terminology, there is the consumer provider model that I want to highlight. So imagine that this is the PaaS service of interest that you want to provide the service for. So that's the provider side, and this whole side is the consumer of that service. Okay, so you will see this consumer provider throughout this session. It is kind of in the base layer, so you will see it throughout throughout all of the options. So let's look at the different terms over here. So going back to my icons over here, we will start first with private link. So private link right in the middle over here enables you to have secure access to any PaaS service. Okay, so that's the role of the private link. Now you have private endpoint, and notice the icon is slightly different. Private endpoint is a network interface that has an IP address, right, which gets projected in your VNet. Okay, so that's private endpoint. And then private link service is, imagine you have your own service, not an Azure PaaS service, but your own service, of course, still hosted in Azure that you want to bring to an Azure VNet, right? So we have a separate layer on that. In this one, I will cover private link and private endpoint. Private link service is in the next layer, all right? Now that we have all of the terminology, let's look at the flows. So there's quite a bit to see over here, and I will, it's color coded, so I'll go over it one by one. So when you enable private endpoint on a PaaS service, in this example, I have a storage account. Two things happen behind the scene. This this PaaS service gets projected into the Azure VNet, whichever subnet that you decide as the private endpoint subnet, and you get an IP in that subnet. And the second thing that happens is you have the option to automatically create a private DNS zone, which is also a recommended option. And that zone has an A record. Notice it has an A record for the storage account. All right, so that's how when you create the service, those things happen behind the scene. And now let's look at the flows. First, we will look at routing, and then we'll look at DNS. So from these orange flows are showing that now that it is in the VNet, we have routing from these peered VNets, right? So this VM and the spoke has routing to this .4 IP, so it would be 172.16.251.4. And then, of course, from an express route connected branch, you have routing. So let's look at the DNS. Again, I could light up the DNS flows. It would get cluttered, but I'll just light it up for a few seconds just so you know how it would work behind the scene. So this is all. These are all the flows which we looked at independently as well. But by the virtue of those flows, this VM, if you run a dig against or an NS lookup against the storage account, you get the private IP. On the peered VNet over here, you also get the private IP. But the most important thing over here is notice what happens to the external user. The external user would still get the public IP. And again, this is by the virtue of how public and private DNS zones work. It would still get the private IP. However, we would disable all public access to this PaaS service. And that is the key, right? So no public access to this PaaS service, and everything is accessed using private connectivity. And you see how DNS becomes very important. I have taken a few screen captures just to show you the consumer and provider flows. You can, of course, automate these flows, but I've put in a link over here to show those. And then let me just make sure I'm not missing anything. Yes, and there is another important concept of security. Remember how in the service endpoint, we were able to, with just one setting, we could expose all of the storage accounts. In this case, you have more granular control. of that instance, and you only project the instance of interest into the VNet, and that gives a lot more security. Again, we continue to evolve this service. We do have we do have network policies for private endpoint that allow you to that give you more granular control with NSGs and UDRs as well. But again, DNS is a core piece. The reason being that this FQDN of the PaaS service has to be preserved just for the SNI header to stay intact. For most HTTPS services, that is required. All right, so with that, let's move on to the next layer, and that is the private link service. So let's see what the use case is for private link service, right? So similar to PaaS service that you saw on the right-hand side before, imagine that this is a service that is your own service, right? That you want to use in Azure. So private link service is a reference to your own service instead of a PaaS service. But it still works the same way. Notice the provider on this side, the consumer on this side. So essentially, this side will be your provider of your service, and this side would be your consumer of the service. So let's look at how the flows would work in this model. There's quite a bit to see in this, and I will go in the depth of IPs as well to understand this better. But for now, just understand that when you first thing you do is you create a private link service. Notice you in this diagram, you'll see all of the icons. So first you do is you create a private link service. That's the icon over here. Then you project that into the VNet, and that's the icon over here. You got an IP in your VNet. And then you have the private link in the middle, right? That traverses the Azure backbone. So when that happens, notice that now we have routing. So the pink flows are showing you routed paths, meaning an on-prem user can route to this IP, and then an appeared VNet VM and appeared VNet can route to that IP as well. So how does DNS work in this? In case of a private link service, there is no private DNS zones, so you have to maintain your own DNS, right? So now let's take a closer look at what happens when you create a private link service. It requires you to give a NAT IP address, NAT subnet. And what is the use case for the NAT subnet? Let's take a closer look at how it looks. The use case is really that you can have overlapping IPs. Shruti is going to go into the details of that advanced use case, but what I would like to show you is how the traffic would look like from this red VM's perspective. So imagine that you are a user over here and you accessed this private endpoint. From this red VM's perspective, of course, by the virtue of this pink flow, you would get red VM's web servers output back. However, from this VM's perspective, this red VM's perspective, you're going to see the source IP as 172.16.200.5, which is the NATed IP on the NAT subnet, right? Now, what if you want to see the actual source IP of the VM that initiated the traffic? For seeing the actual source IP of the VM that initiated the traffic, we have a concept of TCP Proxy v2. So if you enable that setting, what you can do is you can take a look at the packet capture to see the real IP. And a large shout out to Daniel for helping me decode this proxy protocol so that we can actually see the source IP of the packet that initiated the traffic. So it's very similar to the XFF headers that you may be familiar with. And then if you turn on the right Wireshark settings, you can actually glean into the proxy protocol and see the source IP. However, this is just for our own understanding. In the real world, whatever web server that you are using, Apache or Nginx, would be able to decode those proxy headers and do the right thing, right? Just wanted to show you how the headers were decoded. And of course, I've put some links over here. If you are presenting this, this is all kind of ready to go. This is the approval workflow. And just remember that this whole thing could be in a different VNet region and a subscription. All right. So with that, let's go into the next layer. This next layer is often sort of misunderstood when it goes with private endpoint. So this feature is called VNET Integration. So let's see how this is different from private endpoint. There's a lot to see, again, color coded, so I will go each flow one at a time. So imagine that this is your web app and you want to access your Azure SQL database through the private backend IP. For you to do that, you have to enable something called VNET integration for this web app, and that essentially gives you access into the resources in the virtual network, right? So then you can access the private endpoint using this orange line. You can egress from Azure using this blue line. So this blue line is showing that you can use the NAT gateway to egress. The green line, of course, you can continue to access the web app using the public IP. And let's look at real quick, how the DNS resolution works. So I was SSH'd into the container that hosts this web app. I did an NS lookup of SQL database.windows.net, and I got the private IP, and I did a curl on ifconfig.io, and I got the public IP of the NAT gateway. Of course, you can have Azure Firewall here as well, or any NVA, essentially the same services that you use in the VNet. Okay, and a quick screen capture showing what it would look like on the web subnet is that it would show up under subnet delegation. So it shows that that subnet is delegated to a web farm, web.server farms. Okay. And then let's go into our last layer. Last layer is a use case for Azure Front Door with private endpoint. We covered this a little bit in our load balancing section as well, but the use case is that imagine you have a service over here, an Azure Kubernetes service, a completely private cluster, AKS private cluster, and that origin is not routable from the internet. So this red flow is showing cannot route to it from the internet. So what you do is you have this Azure Front Door Premium. Notice you need Premium. And you can enable private endpoints with Azure Front Door Premium. And then you can, by this, if you follow these pink flows, it creates a private endpoint in an Azure managed VNet. And then you can have this as a backend to Azure Front Door. All right. And of course, you can do the same thing. You could use the same concept for other PaaS services as well. If you don't want to make the origin routable or accessible from outside, you can attach it with Azure Front Door Premium. And then it will also work from a different subscription or a tenant as well. So with that, let me just make sure I'm not missing any points over here. Yep. So with that, it ends my part of the session. Thank you again for joining, everyone. It has been a pleasure to host you all, and I'll see you in the next series. Over to you, Daniel.
Thank you, Nehali. Let me share my screen. All right. So in my part, I'm going to cover multi-region private link failover design. And yeah, we don't have a lot of time to cover all the specifics related to, but I'm going to give you guys a few resources to do some homework. And I want to highlight some really great job that has been done already. And I want to share with you guys the work with my colleague Adam Stewart on that space for private link, multi-region design, and obviously focusing on the failover. And so I want to make sure you guys are going to have access to this in the in the notes for this session. However, what I want to spend more time is I put together a demo going over two scenarios, which I'm going to cover, and I want to highlight them here first. But I just wanted to anticipate that in order first you to make your multi-region private link design, which is, in our case, it's related to DNS, right? So DNS is the main component that's going to is going to be the core in order to make this solution to work. But even before we go into the design options that I'm going to highlight here on Adam Stewart's documentation, and I'm going to demo the two major designs using two separated pass solutions. The first one is going to be storage account, and the second one I'm going to use a SaaS bus. Is to highlight that even before you making the decision on how you're going to do your multi-region, you have to understand what the PaaS solution offers in terms of failover or redundancy. So, and I just want to highlight in the article here the two scenarios that I'm going to go over, and I'm going to highlight only using the table of contents because, again, this is very, very comprehensive. And the first architecture that we're going to cover, in reality, I'm going to do the opposite because we have two options here. When you do DNS, prepare your DNS name resolution for multi-region Azure Private Link design. So you have an option where you can add the private link zone per region, which means if I have a storage account, keep in mind that if I have a blob storage account, for example, I'm going to have blob Windows, blob core Windows.net as a zone, which means I have to have one zone. If I have East US and West US, I'm going to have one zone per region in order to accommodate that design for storage accounts. And I can have an option of to have a single region or single zone, which because the private zone in the context of the Azure Private DNS is always a global resource, which means it doesn't really live in a specific region, which allows me to attach, to link them to any region that I need. So for my specific scenario, like I said, I'm going to demo the scenario 2, the option 2 first with a storage account. And I want to demo with the SaaS bus, the option 1. So I'm going to kind of invert the process here so you guys can understand better. So again, I'm not going to highlight all the specifics here because I want you guys have a read. I want to concentrate on my demo because we don't have much time. And let me go for the option 2, which I'm going to have a global single DNS zone. I'm going to bring my whiteboard. I don't have yet the beautiful Drive.io with the layers. I'm still working on that. Let me bring this scenario for you guys first. Let me bring this. Let me get the scenario with the single zone multi-region design. So first, I want to highlight a few things before I go over the design. In this lab, I'm using virtual WAN. As you see, I do have 2 regions, one in North Central US, another one in South Central US. I do have 2 on-premises locations, branch 1 and branch 2, Dallas and Chicago. And my main goal here is to kind of show you first how we're going to make name resolution to work for private link. And in the second part of this presentation, what I'm going to do, I'm going to simulate a failover. And as I explained to you guys, I'm using the option 2 for the previous article, which I'm using a single private link zone for the blob, which is a global resource. And this zone is linked only to the shared services VNETs, which are linked to each respective hub. So as you take a look over here, one thing that I want to highlight is I'm using also a DNS private resolver for this solution. And I'm using everything natively here. And I want to just highlight 2 things here. You can definitely replace this with your custom DNS solution. And the second point, although I'm using virtual WAN, virtual WAN does not allow me to host the DNS private resolver or custom DNS servers inside the virtual hub because it's a managed hub. So in this case, I need a dedicated shared services, which I have for each respective hub in this case. But in the hub spoke model, is totally applicable as well. The only difference here compared to the hub spoke is all the services that I have in the shared service, they can coexist in the same in the hub spoke model inside the hub VNet. So that's the differentiation here. But in terms of flow, nothing changes. I'm just taking this out in a dedicated shared service VNet for the virtual WAN scenario. Another thing that I want to highlight is I do have individual storage accounts in this case. So I'm not doing any kind of re-exposing the same private endpoint to multiple regions. So in this case, each one of those names that you see on the right side, they are storage accounts, which are primary storage accounts, which each one of them are exposed to. I have 2 of them exposed on the South Central region, which is this one for which I'm exposing to the shared services. I'm exposing another one for the Spoke 1 storage account in the Spoke 1. And the main goal here also is to show you with this design, I reduce a little bit of the complexity because, again, I'm using a single global resource, which I'm storing each individual resource record. So all of them are hosted here. I'm going to change the portal in a few minutes to show you guys how that looks like. And another simplification, this design that I'm using, which DNS private resolver, and I know the private resolver is not the main subject here, but it's a private link. In a scenario that I'm not using private resolver, usually you have to link this private link zone as well to the, you have to do this link to the specific VNets in order for them to resolve. But because I'm using the DNS private resolver and I'm using the VNet link rule set, I'm kind of minimizing here in this design the VNet link only to the hub services because when I do have a spoke VNet, a spoke 4 VM trying to resolve in one of these private link storage accounts, they're going to leverage the VNet rule set, and that rule set is going to point to the inbound resolver, inbound endpoint, and that inbound endpoint is going to leverage the private link. So in this case, I'm simplifying here in terms of how the amount of VNet links that I need to create for that design. So I'm going to switch to I'm going to put this diagram on the side because I want to show you another thing. Let me make it a little bit, actually, let me just use this feature here. Point to the left side. Let me bring my Visual Studio Code. And just to show you another thing that I want to highlight, which I do have that simplification, is in my on-premises DNS server, I also configure for the failover process, I'm pointing to the primary private DNS private resolver endpoint, which is respective to my region, because in case I lose that private resolver, I have the secondary connection going to the other hub, so I can also consume the private endpoints on the South Central US, and vice versa. So I'm pretty much like in this configuration, I'm cross configuring the DNS for the conditional forwarder for the blob core Windows.NET to use the each one of the inbound resolvers, as you see on the top of it here. So I have a full scenario with redundancy in this in aspect. If I lose a region, if I lose the private resolver, I'm going to have each one of the other backing up each other. So let me go to very quick, just explain my Visual Studio Code. I put some commands over here to expedite because we have a short time, and I want to make sure I'm not going to make any mistakes. So the first thing is I have my Azure CLI, which I'm going to run some commands against my subscription in order to get some Azure specific configurations. And I do have the branch 1 and then branch 2 VM console open here as well, so we can run some commands. So the first thing I want to show you is obviously the configuration of the each one of my branches, which are pointing to the respective Windows DNS server. If I go to the branch 2, the same thing is happening. And my DNS servers on each one of those scenarios are configured for the blob core Windows.NET, pointing to the 1036 and 2036. Again, I'm in the branch 1. I'm pointing to my private DNS resolver in the South Central US, and this one is in North Central US, and I'm doing the opposite for the branch 2. I'm doing this North Central US and South Central US for the blob core. And as you know, what's going to happen here, the conditional forwarder always works as in the order, which means if the one's timeouts, I'm going to always use the primary one that's defined. If there's one timeout, I'm going to use the second one. So it's always, and usually I'm using the Windows DNS is a 5-second timeout. If I have the first one is not responding, I'm going to use the second one. The second goal here is to make sure from the branches I'm able to resolve all the storage account names. So I have those fancy names, storage account one in Spoke 1, Spoke 2, Hub 1, and Hub 2. And if I run this command, the expectation is I'm going to get, and I want to highlight you, I do have my private link blob core Windows.NET, which is linked only to the shared services on each one of the hubs. And what I'm going to do here when I run this command on the on-premises, for each one of those storage accounts, I'm going to get the respective DNS record because I'm retrieving this from the global private link blob core, which is linked to both of those hubs. Another thing that I want to show you, okay, name resolution is working perfectly. I want to expedite here to show you a scenario where I'm going to bring a failover scenario, which in this case, one of the main points, that's why you need to understand the storage account, how it works, because the name resolution relies in a record, which means, let me bring here this solution where, for example, I'm using this global resource and I want to fail over this hub1 private endpoint in my BCDR process, because again, this is not going to be, it's kind of challenging in this scenario to make it active, re-expose this actively over here. We're gonna have some DNS resolution challenges. I'm also using a single global VNET private link zone, which is gonna not allow me to do a coexistence here. So what I'm going to do, I'm going to simulate, like, let's see in this whole region, South Central US, is going to go down. Assuming this private, the storage account is regional, has regional failover configured, because if I go here on the this storage account, my primary region for this storage account is South Central US. The secondary region is North Central US. I'm not going to do the failover right now because, first of all, one thing that I need to do first in this scenario for the private endpoint is to expose it, the private endpoint in the North Central US, which I'm going to cover with you guys. I'm not going to do because this failover process takes about 15 minutes. But I just to show you guys, if something happens, the platform is going to move that storage account to North Central US. The only thing that I need to make sure, because I'm using private endpoint, is if I go back to that diagram, I need to make sure this private endpoint that's living in South Central US gets exposed to the North Central US, so my users and on-premises, they can get access to this one. The fact that I'm doing this failover, for example, let's say use site recovery, and I'm doing VMs also failovers. And in your recovery plan, what you can do here is, because this is going to be unavailable as soon as I have a regional failover, the fact that I'm creating this one and I'm using a single private link zone is going to override the record, because I'm going to use, I'm using a different name here for the private endpoint object. The number of storage accounts is still the same. So as soon as I do this failover to the other one, as I create this private endpoint, I'm going to override the DNS settings, and now I'm going to get the IP for that hub1 private endpoint and the hub2. And that's what I'm trying to simulate for you guys here. And what I'm going to do is, I'm not going to do the failover to emulate the storage account side. I'm going to just emulate the process of creation that you can incorporate in your BCDR process to re-expose that private endpoint to the other side. And that's what I'm going to do now. Let me run. What I'm going to do is I'm going to run this loop script, which is going to query the same storage account on hub1. If I do this loop script, what's going to happen is you're going to see that I do have always the 10.5, which lives in the 10 network on this side. And I'm going to do the same thing for the branch 2, because I'm using a unique one. I should get the same IP, right? 10.5. And what I'm going to do is I'm just re-expose this private endpoint. Now I'm going to create the hub1 private endpoint on the hub2. And this process is what I'm going to do first is create the private endpoint, and then I'm going to trigger this other command to update the DNS configuration of my private endpoint. So the portion that actually is going to trigger the update of the new private endpoint here is going to be this second command. I'm going to just run the whole thing. And what's going to happen is, oops, I'm running in the wrong screen. I need to go back to the Azure one. So let me select. So when I run this command, what's going to happen is, and I want to show you guys the portal because it's going to get better visibility. What I have in the private link center right now, I have that hub one private endpoint, which I'm doing the failover, right? Which is resolving to 5, as you see in this entry. And what is going to happen is, as soon as I'm creating that second private endpoint backup, which if I'm refreshing here, is in the process of creation at this point. I haven't got any IP yet. But again, I'm using the same exactly storage account. The only thing that I'm doing, I'm exposing this storage account in the other region. And hopefully this is going to run quickly. It's running. And my expectation is as soon as I get, so I got this 20.8 IP, which I just exposed. When I have the second part of my command, updating the DNS configuration of my private endpoint, the expectation is, which just happened. As you see here, I have a transition of this resolution now from that name of the that storage account now failed over to the other region. So in this case, it's just a representation on how we can do the failover using a single global zone. And I'm scripting here, and I do have a second scenario. I don't have time to go over, which I'm going to just explain you guys really quick here. And maybe I can do the failover quick just because we still have the time for Shruti. But the second scenario is the way that SaaS bus works is different from the storage account. Storage account uses an array record, but some other PaaS SaaS like SQL, Azure SQL DB, SaaS bus, which is this scenario over here, they have this concept of primary and secondary. So I can create a primary SaaS bus in North Central US, like I have in the left side. But I can create a failover, a regional replication, and when I create this regional replication, they I specify a secondary, which is in the South Central US, in this case. So in this case, as you see, I expose the SaaS bus twice. As I have 4 private endpoints. I do have 2 individual private link zones, because in this scenario, what it brings me different the other one that I just showed you for the private endpoints is it's more like a failover scenario, which I'm going to have some downtime, and I'm using just a single zone because of the behavior of the way that the storage accounts work. It cannot leverage a CNAME in the storage account. But in the SaaS bus, I can use this active scenario where I can expose the SaaS bus in both sides, which means every time that I'm using the primary, I'm hitting always the respective private endpoint. And when I'm doing the failover, is just going to update the main name of the which is I would say the master name. Is going to do a CNAME change between the name of the North Central US to the South Central US. So in this case, what happens here, which I can demonstrate to you guys on the demo 2 very quick. Let me go to the demo 2. Let me stop here. And that should not take too long. When I do the name resolution for SAFS bus in the, let me do it clear. So you take a look that this master name of the SAFS bus that I'm using, it's currently pointing to the CNAME of the SAFS bus North Central US, which is the primary one. So with this technique that SAFS bus offers, when I do the failover, what it does behind the scenes is it just changes this to the secondary one. So which means right now, if I'm resolving the primary because I expose the private endpoint in both sides. So what I'm going to do, for example, this one is getting the 26, and if I go to the hub one, the branch one, and I do the same name resolution, I'm getting the 10.6. Let's just go back quickly here to the diagram to show you guys quickly. Let me put this on the side. So what I just did the resolution here, as you see, I resolved on the branch to 20.6, which is this one over here, which is my primary. What I've done in the branch one, because I have this active expose, this active is also exposed as 10.6. So how I'm getting this name resolution, I don't get always the same compared to the storage account, because now I broke down this in two separated zones dedicated for each region. So when I do the failover in this case for SAFS bus, and you guys are going to see this really quick, and let me do it. So I'm gonna just run a quick loop command here to highlight that. So in the branch one, we're getting the as you see in the branch one, I'm getting the IP of 10.6, which is the primary one. If I run the same command on the second one, I'm going to get the 26, which is my primary one. And what I'm going to do is I'm going to simulate a failover in the SAFS bus. I haven't shown you guys the details on the SAFS bus, but this is how it looks like. So this is the failover configuration, the geo failover. In this case, I do have North Central US as my primary. I have South Central US as my secondary. And I'm going to just simulate the failover. So when I do the failover, what's going to happen behind the scenes? I need to type the name here of the alias. No space, failover. What's going to happen behind the scenes is going to change the CNAME from the North Central US to the South Central US, which means what's going to happen with that diagram, we're going to see that we're going to have a seamless failover. I'm going to get now, my expectations is to get the 27 on the branch 2, and to get the 10.7 on the branch 1. So let's see if that's going to work. Just wait a few seconds, and I'm going to hand it over to Shruti just to see if we can see that failover. It should not take more than 1 minute. Let's see. It should change both sides to 7. And just to wrap it up really quick here. So both scenarios that I just demonstrated to you is, okay, you can do a global one, a unique one, which makes your life much easier in terms of the private link design. You can use the solution with 2 separated ones, but again, what's going to determine your design is going to be what kind of failover or mechanism of a name resolution that your PaaS solution supports. And I just want to highlight, yeah, I just see here the failover worked, 6 to 7, 26 to 27, worked perfectly. And if I go back to another thing that Adam Stewart has done a really good job, he kind of broke down per PaaS service what would be the recommended solution. So I'm gonna make sure you guys have this as well. He has done some amazing videos on that. And as you see over here, over the SQL Azure SaaS Bus, you can use either a single or a double one depending on the solution, right? In my case, I'm doing like a separated one because I'm using the active scenario, right? But you can also use the single one. But I recommend you guys the one that I did for the storage account requires you do some user intervention because that's what I did when I created the new private endpoint. But in the scenario of the SaaS Bus, it was completely seamless. I haven't to do anything with my private endpoint because the past apps bring me that capability of the failover. So I know I'm really over. I'm going to apologize to going. I hope you guys enjoy the session, and I will share also this lab in the notes as soon as I have it ready, so you guys also can do some hands-on practice. That's the end of my session. I'm going to hand it over to Shruti.
Thank you, Daniel. Let me just share my screen. Okay, hello audience. Today I am here to present a specific scenario which we see very often these days where, with mergers and subsidiaries who work on their own environment, Azure environments, there comes up a requirement every now and then where the main business unit needs access to certain services that the subsidiary is hosting. But what was not considered initially, or which was not part of those initial discussions, is now there are overlapping prefixes, so they cannot have direct connectivity. But it could also be more than that, where they do not want to have a full-fledged peering kind of connectivity due to security concern. So what I want to get through this scenario that I'm going to discuss is what are the options that we have when we have these overlapping prefixes. As Nihali already alluded in the earlier, yes, you could use a private link service for that, but how? If private link service doing it with the application itself is not an option or is not an optimal option, how can you get these things done? So how I'd like to start is, let me quickly start by talking about the image that you see on the screen. What you see on the left is very similar to what Nihali has been sharing for the past hour. So this is let's say, the business unit's existing hub and spoke infrastructure on Azure with connectivity to branches and headquarters, respectively. What you see on the right is the subsidiary unit which has its application hosted behind an application gateway. Now there could be more applications hosted here, but I just wanted to keep it clean, and we just have to concentrate on the service that we need access to. What you also see is in the subsidiary environment, there is connectivity to an on-prem branch subsidiary office. With this, there are overlapping networks between the main business unit, headquarters, and there's overlap between the Azure networks that is being used by the subsidiary. In that scenario, how can you establish connectivity to the resources that's in the subsidiary? It could be your VNET resources or apps in the VNET or your branch office. So for example, Spoke 1 here needs connectivity to the apps that are hosted here, also needs connectivity to the services that is hosted on premise. Now, in a typical scenario, as you know, I think this was also covered in the earlier session, application gateway, we have an option to set private link service directly, but it's not GA yet, it's still in preview. So with that, if you have to go production now, right, what are the options that you have? How can you get that done? Now, if you look at what I have drawn in the middle is an NVA, a set of NVA. This could be existing something in the substrate where they already have a set of NVAs. This could be HA proxy, Nginx, or any firewall that's capable of DNAT, hosted behind a load balancer. We have the previous session, which was conducted, was on high availability and NVAs, which will go in details of how the setup works. So I will not touch into the depth of that. So let's just start looking at from a connectivity perspective. Now I can have a load balancer with the NVAs hosted behind it. So in that case, what will happen when spoke 1 tries to connect to the app gateway here, and how will it start? So I will establish a private endpoint, private link service connectivity, a tunnel between my hub and my private link service with the load balancer. Now, when the spoke initiates the connection, it goes to the private link service, goes to the private endpoint, private link service, and then to the NVA. Again, now when the packets make it to the NVA, right, they see the traffic coming from the NAT IP, that is the PLS IP 172.16.200.5 in this case, and the destination will be the NVA IP itself, right? Now, NVA, using its capability to do destination NAT, will use translation based on IP port and forward that traffic to app gateway. This way, we establish a full-fledged connectivity from this portion from the left, that is the main business unit, to the subscription or the tenant services that is hosted in the subsidiary. At the same time, you're also not exposing all the services you have on your left, meaning these apps cannot connect into your services because you have not set up a private link service there. And that has been a requirement for most of our customers where they do not want the subsidiary to have access. Now, the same concept can be applied to traffic that needs connectivity to on-premise services, meaning the spoke initiates the connection, same PLS. Now, again, the NVA, based on its IP port translation, will forward the traffic to a destination that is hosted within on-premise. Now, with these things, we have to keep in mind a few considerations or limits. Let's talk about. When we talk about PLS, we can have in a single load balancer, you can have at a max of 8 private link services, meaning this is a single private link services. You can establish private link services on multiple IPs on the load balancer itself, but at max, it can go up till 8. With that, in a single private link service, you can also have the NAT IP that we talk about, right? You can have up to 8 NAT IPs. This gives you a little more flexibility when it comes to scaling, with one IP. What if you run into some kind of port exhaustion, what your options are. So in that case, you can go up to 8 IPs, gives you the flexibility to increase the number of NAT IPs. So this is what I wanted to show. This is a simple use case, but how you can use an NVA to do those DNAT and achieve connectivity without having to tweak a lot in the existing environment, and take all the benefits, reap all the benefits of, let's say, app gateway functionality that you have with the connectivity without a lot of changes. So that's about it that I wanted to bring up. And thank you so much. I hope this was informational. With that, I hand it over to you, David.
Great, thank you. Thank you all for joining us today, and thank you for joining us for this series. Please take a moment to fill out the feedback form posted in our Q&A. And as always, remember to visit aka.ms/AV networking sessions for the content covered today and the content covered in our past events. Thank you again.